The process begins in the log yard. Pine logs arrive by truck and are unloaded using hydraulic grapples. Each log is measured for length, diameter, and curvature before entering the line. Nothing moves randomly. An automated conveyor system feeds logs one by one, ensuring constant flow into the mill without bottlenecks. Each log is tagged digitally, allowing the system to track it from the yard to the final lumber bundle. The process begins in the log yard. Pine logs arrive by truck and are unloaded using hydraulic grapples. Each log is measured for length, diameter, and curvature before entering the line. Nothing moves randomly. An automated conveyor system feeds logs one by one, ensuring constant flow into the mill without bottlenecks. Each log is tagged digitally, allowing the system to track it from the yard to the final lumber bundle. Before a single cut is made, every log is scanned. Laser scanners map the external shape in milliseconds. X-ray systems peer inside the wood, detecting knots, cracks, and density variations hidden beneath the bark. Using this data, software calculates the exact cutting pattern that will extract the maximum amount of usable lumber from each log, down to the millimeter. Waste is not an option here. Optimization is everything. Next, logs enter the debarking drum. As the drum rotates, friction strips away bark without damaging the wood underneath. Clean logs protect saw blades, reduce contamination, and improve cutting accuracy. The removed bark isn't discarded. It's collected and reused as biomass fuel or landscaping material. Nothing leaves this mill unused. Now the real cutting begins. Logs are fed into the head rig, a high-speed bandsaw capable of slicing through solid pine in seconds. The first cuts transform round logs into flat slabs and square cants. Blade position adjusts automatically based on the earlier scan data. Sawdust generated here is immediately extracted through vacuum systems and redirected for pellet fuel or particle board production.
The consistent movement and uniform dimensions highlight the efficiency of the primary breakdown, a seamless progression towards the next stage.
Squared cants move deeper into the mill. Resaw machines slice them into boards of specific thicknesses. Each board is monitored in real time for straightness and dimensional accuracy. Boards that fall outside tolerance are diverted instantly. No manual inspection required. Speed and precision operate together.
The wood's inner beauty, now exposed, is ready for its purpose, a promise of strength and utility.
Freshly sawn boards still have rough edges. Edging machines trim both sides, creating perfectly straight, square edges. High-speed saws cut boards to standardized construction lengths, 2.4, 3.0, or 4.8 meters. Every cut is guided by optical sensors. The result? Uniform board ready for drying. Before drying, boards are sorted. Thickness, density, and moisture content determine how each board will be dried. Grouping similar boards ensures even moisture reduction and prevents defects. This step is critical. Incorrect drying ruins lumber, no matter how well it was cut. Boards enter massive kiln chambers. Over the next 24 to 72 hours, temperature and humidity are carefully controlled. Heat gradually rises from 60 to over 100 degrees Celsius. Moisture content drops from more than 50% to just 10 or 12%, ideal for construction use. Sensors embedded directly into sample boards provide live feedback, allowing the system to adjust conditions automatically. Too fast, and the wood cracks. Too slow, and productivity collapses. After drying, boards are conditioned. Temperature and humidity are stabilized to relieve internal stress. This step prevents warping once the lumber leaves the mill. Only stable wood moves forward. Now precision matters. Boards pass through four-side planers that shape all faces simultaneously. Rotating carbide blades spin at thousands of revolutions per minute. Dimensions are brought to exact construction standards. Mechaniforschene Uhrschirkel with tolerances as tight as 1/10 of a millimeter. What began as a rough log is now a precise structural component. High-resolution cameras inspect every board. They detect twisting, bowing, surface cracks, and knot size. Boards that fail structural standards are downgraded automatically. Only lumber suitable for load-bearing construction continues. Each board receives a structural grade. Based on fiber alignment, not distribution and density, lumber is classified as stud grade number 2 or select structural. This grading determines exactly where the lumber can be used, from framing walls to supporting heavy loads. Some boards receive additional protection. They're treated with preservatives that resist insects, fungus, and moisture. For outdoor use, pressure treatment forces chemicals deep into the wood fibers. Durability here is engineered, not accidental. Finally, finished boards are bundled. Steel straps secure stacks of lumber. Each bundle is labeled with size, grade, and kiln batch data. From here, lumber ships directly to construction sites, hardware suppliers, and manufacturers, ready to become part of real structures. This is how raw pine logs are transformed into construction-grade lumber with precision, automation, and relentless efficiency.